Hello and welcome back to our last segment on Lab 7 Earth Sun relations. We're just simply going to talk about contouring and looking at how those contours vary over the surface of the Earth. This is page 83 in your lab book, so you'll want to take a look at this contour map. And if you have been having trouble completing the contours, I'm going to do a few with you here. Just reviewing some of the rules for contouring. These are temperatures. And we're going to contour them in isotherms, or we'll call them contours of temperature or isotherms. We're going to contour them in with a contour interval of 5 degrees Celsius. I'm not going to complete all the contours, but that means, based on our data range, which starts down here at like around 3 and goes up to, let's see, 17, 23, 22, 26 over here, that we could do 5, 10, 15, 20, 25, 30. We could actually start at 0, though, 0, 5, 10, 15, 20, 25, 30, and so on. So I'm going to start down here on the bottom left-hand side. I'm going to start with a temperature of 10 degrees Celsius. So I'm looking around for places where I might have 10 between these data points. I don't actually see any values of 10, but I do know that there's a 10 value right there. Okay? And I do know if I look around a little bit. Oops, I went a little bit too high. Sorry about that. Let me back up. The 10 is lower. So I know there's a 10 value right there. Okay. And if I look around, I see that there's probably a 10 right in here. Okay. Moving to the right between 17 and 16, there's a 10 in there. We've got a 19 and an 8, so there's going to be a 10 in there. Oh, I lucked out. There's a 10 actually. There is a 10 value there. And then coming over here, there's also a 10 there. And so I can connect up all my data points here like this. Oops, went a little bit low there. Come back up to 10, and then through here and to the edge of the globe. Okay? So that's my 10 line. Now I want to do 5, so I got to go lower, right? So if I wanted to do 5, we can plot our own data. Remember, 4 to 7, there's a 5 right in there. 4 to 6, there's a 5 right in there. See, 3 to 8, going to be a 5. 4 to 7, going to be a 5. And connect them up with a smooth line, and we'll just label that with a 5. Okay? Now, in the wintertime, in the summertime, we see different temperature distributions. What we do want to note, though, here is where things get a little tricky. For instance, when you start contouring the values of 30, notice values of 30, here's a 21 and a 31, so there's a value of 30 there, value of 30 there, 20, no 30s up here up top, so there's a 30 in here. Between 30, you see 31 and 26, there's a 30. So actually, you're going to find that some of your values of 30 are going to just loop around like this. Okay, so over the continents during the summertime, depends on what month this figure is drawn for. Okay, if it's in December, it's going to be hot in the southern hemisphere. We'd expect to find sort of bullseyes or circular contours over the continents. So you'll want to check that for Australia and in Africa as well. If we go up top to the northern hemisphere, you're going to start seeing contour lines get more closely spaced together during the winter seasons, which is December, or the December solstice. If we wanted to start out contouring, we could start out with the 0 contour, which between negative 33 and 2, we might find a 0 right there on the top left-hand side. Coming through, 0 line in here, 0 there, 0 there. Okay, coming out, negative 20 and 8. Let's see, 0 maybe right in here. We got to shoot up. Can't go straight across. That's 2 and 6. There's no 0 between 2 and 6, so we got a 0 there. We're coming around 0 in here, okay, between 2 and negative 6. Plotting that data point. We're going to come down close to 2. And this is negative 6 and 13, so we got a 0 in there, and a 0 in there. So if I started to connect my zeros up, you see they come down over the continent, go up. Oop, made a little mistake there. Gotta go around that 2. Up over the ocean. Back down as I come over the continent. Okay. Now we're going to go through close to this 3, up by the 8, and then off. Okay. So during the winter time, you can actually see that the cold air is localized over the continents during the winter months in the northern hemisphere. Okay. And it would flip-flop so that during the June solstice, the high temperatures would be over the continents in the northern hemisphere. So you'll contour at 5 degree increments, and then you're going to do a little gradient calculation here. Okay, A to B. Notice you have a map scale down on the bottom right. So just remember you can measure the total distance in centimeters, okay, if you want, and then divide or then take the total kilometers. Let's say this is 2,000 kilometers divided by whatever centimeters you get for the length of that scale bar, and simplify that to get your conversion factor, okay, which will allow you to calculate your distance. Here, your map distance. And then once you finish the contours, you're going to figure out the change in temperature from A to B. Okay, so your gradient, you'll remember, in temperature is equal to delta, okay, temp divided by distance. Delta temp is equal to, the temperature of A minus B divided by distance. All right, so that's how you go about finishing your contour. Remember, most of the time, you've got to really plot most of the data that's in front of you, so you're not going to get a lot of data points with lines passing through them, and that can be a little confusing.